Okay, so we'll be talking about watts. Watts. Many of us have been hearing about watts. W-A-T-T. I know you will say, I know it already. It's the unit of measuring power. Yeah, it does not just end day. There is so much about watts that you're gonna be understanding in this video. And by the time you are done with this video, you will become the watts Superman, the watt master. You will be able to manipulate watts at any point in time. Okay guys, in this experiment, we are going to force a certain amount of current through two sets of resistor. The first resistor will be a standard 10 ohms quarter watt resistor, and the second resistor will also be a standard 10 ohms quarter watt resistor, but with a little bit different external property. So let's begin the experiment. This is a 10 ohm resistor. I'm going to connect it across these two outputs. And then using this variable resistor, please note, this meter measures the amount of current we force through the resistor. So I'm going to gradually increase the current through the resistor while we notice the reading on this meter. You see, currently the meter begins to read 0.08 milliamp. Now it's 100 milliamp, 300 milliamp, 400 milliamp, 600 milliamp. If you notice, the resistor begins to smoke, and now we are at 900, 1000 milliamp. So we are going to use a resistor of the same size but different external property. This is the same size of resistor, but in this case it is being submerged in water. I'm going to flip the switch and send in the same amount of current, and let's see the behavior. If you look at it, the switch is on. Look, the meter is reading 0.98 milliamp, which is almost 1 amp of current. But yet the resistor is not bad. Nothing is bad. Nothing is happening to the resistor. It's not burnt, nothing. But yet the resistor can now handle that amount of current, as you can see. So we will do something. I'm going to remove the resistor from the water. Let's see what happens. Now, are you ready? 1, 2, ready, go. Wow. You see what happens? Now the resistor is burning out because it's out of the water, as you can see. Oh, that smoke almost suffocated me. But thank God I'm still alive. So, did you enjoy the experiment? Now, I'm going to carefully break down everything that happened in that experiment. Have you ever wondered why different resistors of different wattage have different body size? Or have you ever wondered why an external heatsink is being applied to your computer processor? Or have you ever wondered why an external heatsink is being applied to your power transistor in your inverter? All is because of this same reason. Now, when you talk about the efficiency of a system or any electronic component, it is in its ability to dispense heat faster. Heat kills, high temperature kills. Even the sun is slowly reducing your lifespan. That is why it's not good to expose yourself to extremely high or low temperature. Either kills you. Now, when an electronic component is being designed, or when you talk about watts or power of an electronic component, it falls in its ability to dispense heat faster. So the faster the component is able to dispense heat, the longer the lifespan and the more current it can actually handle. It does not really affect the current aspect. I will make a video on that. Now, if you look at that resistor, you find out that the one that was submerged in water could withstand the high current that was sent through it, but the other one could not. Why? Because the one that was submerged in water had the ability to dispense its high temperature faster, but now for the other one could not, because heat accumulated around it and became a life shortener. So that's exactly what happens. So whenever you are faced with a situation, let me take for an instance a resistor. Whenever you are faced with a situation where you have a quarter watt resistor but you want it to do the work of 1 watt, all you need to do is look for a cement and apply it on the resistor. Increase the body size, because the higher the body size, the more temperature it can handle and the higher the wattage becomes. If you break most of your resistor, you find out that it is just, have you ever seen this resistor? This is about 5 watt resistor. This 5 watt resistor has a 2 watt resistor inside. There is a 2. When once you break it, you will see something like this inside. So what did they do? They just increased the body size by allowing it to dispense heat faster. So that's what you need to know about it. I hope you loved that experiment and I hope you learned a lot in this video. Thank you. Please like and share. And if you love electronics, follow me on my YouTube channel so we can all learn together.